Okay, so last week you all practiced investigating circuits that just had one voltage source, like one battery, and one resistor or a light bulb connected to that, and really just one output. And we also practiced measuring current in those circuits. So one thing I just quickly did, I grabbed this ammeter, which is what we'll use to measure currents through these circuits. So an ammeter is called that because amps are shown in the shorthand with just an A. So over in your table, and this is the table that you'll fill in for question number 3, or it's really sort of the second real question for Monday's work. Um, but those units for current are amps, which start with an A. That's why a thing that measures current is called an A meter. And the way that we measure current running through this circuit, or especially running through like maybe this resistor, is I take these little crosshairs from the A meter and I put it in contact with our circuit, with a wire in our circuit. And I can see right now that the current running through this circuit, right now the resistance is 20 ohms, but it should be, based on the questions that I ask here, it should just be 10 ohms. That should be the default if you pull out any of these resistors, is 10 ohms. Um, One thing you'll notice here, I'm starting to use these resistors only really because when I click on this diagram button to show like one of those schematic diagrams for our circuits, this is usually the way that a circuit will be drawn. People don't usually spend a lot of time drawing a battery or drawing one of these, like resistors with all of these colors in one of those diagrams. So I'm going to work with this today, where this is our most common symbol, or the universal symbol for a battery. This is sort of our universal symbol for a resistor. Um, One question you might be asking is why we use these resistors if it's not really something that does anything. It's not like a light bulb where there's like a practical application and it lights up. Resistors, they control, or they allow you to control the flow of electrons or the flow of current in your circuit, or to different parts of a circuit. So like a basic application would be, I might know that I have this light bulb and maybe my battery is like too powerful to run current effectively to this light bulb without the light bulb exploding or without it exceeding the power rating of that light bulb. So maybe I would put a resistor ahead or somewhere in that circuit to slow down some of the current and prevent that light bulb from burning out or something like that. But these resistors are a huge and useful tool belt or a tool in the tool belt of an engineer or someone designing any circuit. So that's what I'm going to use here. Now the question for us this week is, how will the behavior of our circuit change, or will it change if we put more resistors in this circuit, or more, it could be a light bulb in this circuit as well. They behave the exact same way, like physically, in terms of obstructing current flow if they have the same amount of resistance. So I'm going to leave all of our resistors, or if you decide to use light bulbs, that's okay too, but I'm going to leave all of those resistances at 10 ohms for this investigation. So for this investigation, I ask you to do this, or to measure the current with 2 of these 10 ohm resistors, 3, and then 4 of those 10 ohm resistors, and see what happens to the current as you increase the number of resistors in series. And I believe I reviewed briefly what that means last week, what like the term in series means. But again, that just means that these resistors are connected in such a way that if current goes through one of them, it has to go through the other. Our current doesn't really have options, or the electrons flowing through this circuit don't really have options. And of course, I'm speaking as if these electrons are sentient, but clearly they don't. But there's only one path for these electrons to take as they travel around this circuit, and they have to go through both of these resistors right now. And so you would measure the current to fill in this table right here, just the exact same way as you did before. I won't do that here because I'm not trying to give away any answers. But then you could sort of cut this tie and then put another resistor in there, and you could, for that four resistor circuit, you could even put that there as well, and then measure the current and see how that current is affected for each number of resistors in this series circuit.